A commercial plane flies at 540 miles per hour at an altitude of 30,000 feet. What is the Mach number? So what we're going to have to do here is we're going to have to calculate out the speed of sound to calculate out the Mach number. So the first thing we have is we have the velocity, 540 mile per hour. Now obviously this isn't going to work so well because we're going to need to put it in feet per second. It doesn't matter if we go feet per second or meters per second. Let's use metric units for the heck of it, why not? So let's look into our book. Actually, in the engineering manual, we do have a meter per second, mile per hour conversion factor. And so if we use that, we will find that the velocity we're traveling at is 241 meters per second. So to calculate out the speed of sound, A is equal to kRt to the half. We're dealing with air, so we know that the K value is 1.4. We know that the R value, because we've used it quite a bit in that perfect gas law, is 287 joules per kilogram Kelvin. But we don't know the temperature. Now, this is one that we'll have to look up. And actually, this problem I really couldn't give you because you may not have the resource for this. So if I went to one of my flight books, there's actually a standard temperature per altitude table on there. So if we look up 30,000 feet, the temperature at 30,000 feet would be 229 Kelvin. And so we raise that to the half because it's the square root. And so we will find the speed of sound is 303 meters per second. So Mach's number will be the velocity divided by the speed of sound. So 241 meters per second divided by 303 meters per second. And that will give us a Mach number of 0.8, which is fairly typical for a commercial airliner.